we are going to discuss about the modulus function in this video, and we look here that what is the modulus function. This is an important function which are usually used in the several branches of mathematics. So we are going to look here that what is the modulus function. The first is definition of modulus function. Modulus function fx equals to mod x. This is read as mod x, and this is equal to x if x is greater than 0, greater or equal to 0, and if x is less than 0, then modulus of x equals to minus x. This is also called modulus function, modulus or absolute value function. Absolute it always takes real values, and it always takes non-negative real values. Its domain is a real number, domain set of real numbers, range equals to set of all positive real numbers including 0, all positive real numbers including 0, that is 0 to infinity, that it always takes non-negative values. For modulus of minus 2 is equals to minus of minus 2. Why minus of minus 2? Since x equals to minus 2 is less than 0, therefore mod of x equals to minus of minus x, minus of x, that becomes minus 2 equals to 2, and this becomes 2. Therefore modulus of 4 equals to 4, modulus of 3 equals to 3, and modulus of minus 1.3 equals to minus of minus 1.3 equals to 1.3. Thus modulus of x is always greater or equal to 0 for every x real number. The graph of this function, the graph of this modulus function fx equals to mod x is like this. This is x-axis, this is y-axis, and 0. The corner point is, this branch is called y equals to x, and this branch is y equals to minus x. The 0 is x equal to 0 is the corner point. At this x equals to 0, we look in continuity and differentiability that x equal to 0, fx equals to mod x is continuous, but not differentiable at x equals to 0. Why this is not differentiable? Differentiability means the function has unique tangent. At x equals to 0, the function has not unique tangent, because there at the x equals to 0, in the right, the tangent, if it is a tangent, the slope is 1, the slope is 45 degree, tan 45 degree equals to 1, and in the left side of the 0, the difference at the left side of the 0, the slope of the tangent is minus 1. Tan 45 equals to 1, and tan 135 equals to minus 1. So there is no any unique tangent at the x equals to 1. So the fx equals to mod x is continuous but not differentiable at x equals to 0. Why continuous? Because there is no any gap, there is no any break in the graph. So similarly for mod x minus 1, the function is continuous but not differentiable at x equals to 1. At x equals to 1, since the graph of this function is the corner point is at x equals to 1, and this intersect x axis at y equals to mod x minus 1, and this graph intersect x axis at x equals to 1, and at y axis, for y axis intersection, put y equals to 0 minus 1 equals to minus mod minus 1 equals to 1. So this point is 0 comma 1, and this is 1 comma 0. Again, we have given some function fx equals to mod x plus mod x minus 1, and if we write it in piecewise function as a piecewise function, so if we have three limits, it changes the sign at x equals to 0 and x minus 1 equals to 0, x equals to 1. So we have three regions. So to discuss, fx equals to, for fx equals to x less than 0, x less than 0, mod x equals to minus x, and x minus 1, x minus 1 is always, x minus 1 is also negative. X minus 1, if we put any number less than 0, x minus 1 becomes also less than 0. So therefore this becomes minus x, and this becomes minus x minus 1. For 0 to 1, for x lies between 0 to 1, mod x equals to 1 x, and x minus 1 is also less than 0, and this becomes x minus 1 is also less than 0. So therefore this function becomes x minus x minus 1. And for x greater than 0, mod x is equal to x, since x greater than 1, mod x equals to x, since 1 is positive, 1 is greater than 0, and mod x minus 1 is also positive, x minus 1 equals to x minus 1, mod of x minus 1 equals to x minus 1. So therefore this function becomes x plus x minus 1.